Hello students and parents, hope you're doing well. This is actually a second video on addition and subtraction using base 10. The first was broken up into two parts, and this might be a little easier explanation. We're looking at how we're using base 10, not necessarily doing the addition and subtraction just to get the sum and the difference. We want to be flexible with how we can explain ways of solving problems using math. In this case, particularly base 10, just like we did with our area and perimeter model. We aren't just trying to find answers to the questions, we're trying to come up with ways of looking at how math actually works. I might have not done a very good job in explaining using base 10 for addition and subtraction. First thing I want to point out is these are identical except for the operation. This is subtraction. And this is addition. Some students, not all, wrote the same in both areas, thinking that since these numbers are the same, the operations are going to be the same. And I want you to pay attention to the operation, not just the numbers. Okay, I'm going to show a couple of different ways of thinking of how to do this. Again, we're taking a standard number, that's what they call this, a standard algorithm, and we're going to expand it into its place values. Now, there's a couple ways we can do that. We can just say I have 4,000 here and not include the 3 zeros that go with thousands. We could say I have 3 hundreds here and not include the 2 zeros that go with hundreds. Same thing for the tens. We have 6 tens and we have 8 ones. Ones don't have any hundreds. Same thing for the number that's at the bottom here, the other addend. Everyone did mostly well with that. Now these zeros for place values can be added up here with your numbers if you like, or could be added down here. Either way is correct, but you have to include these place values at some point on this side, solving the problem using place value algorithm. I'm going to go ahead and just include them. Since they show it up here for me, and I know that this number is 3,000, I know what 3,000 looks like. I'm going to do the same thing for the hundreds and the same thing for the tens. Now we did expanded notation before from a standard algorithm or a standard number, and we're doing it again, except we're explaining how we do addition with this. So my 6 and my 8, if I add those together, I get 14. We know that this is a 10 because we can't put 14 under the ones place, and that this 1 should come over here. But I'm going to leave it like this for now. We can do the same thing for our tens over here. We have a 0. We can add 9 and 6, and that's 15. And we know that this 1 over here is in the hundreds place. And we can move it over there, but I'm going to leave it as it is for now. This we know is 800. This is super easy math. And this we know is 7,000. Now we could do some column addition, just like we did here with our addition up here. We could add these without changing anything. And we could say we have 7,000, we have 800, we have 150 in the tens place, that's okay, and we have 14 in the ones place, that's okay. We can add these together, and we got 4 here, we got 5 and 1, that's 6, we got 8 and 1, that's 9, and we got the 7,000s left over. That would be one way of doing it. Another way of doing it is you could move your hundreds over here and say, okay, I'm going to put this 100 over here. I'm going to put this 10 over here. And then we'd have 7,000 plus, this is 900. I'm doing some mental math right here. This is 60. And this is going to be 4. Let's add that up. We have 7,964. The same answer, the same sum. So this is the kind of flexibility I want students to be thinking about, is how we can use base 10 to rearrange numbers in ways that make it easy to look at them. Right now it's very easy because you're used to addition, but when we get into multiplication and division, we're going to do some complicated manipulation of numbers. It's good that you know how the base 10 number system works. Okay. And then over here we could just use our standard algorithm. 8 and 6 is 14. That 1 with that in that 1's place is not 1, it's 10. I hope you're noticing that. I like to add the 9, the 1 is 10, and the 6 is 16. Well, we say 16, but it's actually 160, and that 100 goes in this place. It's 16 tens, but we're moving that hundreds over to the hundreds place. 5 and 3 and 1 is 900. There's nothing to move over here because it's less than, we don't have a place value we need to move over, and then it's 7 here. So we got 7,964 here, 7,964 there, 7,964 there. That's knowing how to add using base 10. I hope that was helpful. Let's look at subtraction. Same thing. I'm going to expand my notation here. And it's really handy in subtraction to use your place values. 3 zeros in 1,000, 2 zeros on hundreds, 1 zero in 10. Now, you notice in subtraction, this number at the top has to be larger than the number at the bottom. And we have several circumstances where that's not the case. Here it is. Here it isn't, here it isn't. We're still going to start with the ones here, and we're going to deal with these. I'm going to show you how to deal with these in the same way, using the base 10 to evaluate how we're going to move numbers between place values. I'm going to give you a hint. The place values are going to move this way. The arrows are going to go this way. Here the arrows went this way. Here the arrows go this way. So we're going to take 8 minus 6, that's 2. That is first grade. We're going to take, well, we can't take anything here. So we're going to have to take one of these hundreds and move it into the tens. So this becomes 200 because I'm taking one out of this place and moving over to the tens place. Watch how I do this. I'm going to mentally just include 100 in here. Now I have 160 or 16 tens. You can look at that both ways. But the math comes out the same. I subtract the zeros. Now I have 16 minus 9. Remember, we're subtracting. 16 minus 9 is 7. So that gives me 70 here. And I should put this under the values in which they belong right here. I have 200 minus 500. We know 200's smaller than 500, so we can't subtract from it. So we're going to take one of these thousands. That's going to give me 3,000 over here. Now watch how I add this 1,000 to it. I can just add mentally 1,000 to 200 in my head. Now I have 1,200. That's much larger than 500, so now I can subtract. Subtract my zeros. I have 12 minus 5, that's 7. And I moved my zeros over again. Ah, Mr. Budinger has some bad habits, huh? But I'm correcting them. If you have bad habits, I want you to correct them also. Over here, I have 3,000 minus 3,000. That's 0. When we're dealing with whole numbers on the left side, we just don't include anything. So this is what's called a not sign. It means we aren't going to include anything over there. And again, these are like this, right? So if we take 770 and 2 and we add those together, we get 772. That should be our difference over here. That's what we call our solution, difference. And for here we call sum. I'm hoping you all know the sum. Difference might be a little bit new. So let's do it here using the standard algorithm. 8 minus 6, not too difficult. Here we have 6, which is too small, but it's in the tens place. 6 minus 9, we're going to have to take a hundreds over here and move it over here. That's 16 tens. Just like we had over here. 16 tens are 160. That's what it looks like when we're doing the standard algorithm. 16 minus 9, we're going to get the same answer, 7. Since we don't include the zeros over here. 2 minus 5, 2 is too small. We're going to take one of our thousands. That makes this 3. And we're going to move one of our thousands over there. That makes that 12. It's really 1,200. These are not 12 as what we think of as in tens. It's in the hundreds place. So that's 1,200. 12 minus 5 is 7. Over here we have 3 minus 3, again in the thousands place, and that's not. And I'm not going to put anything over there. You guys should already know that. So we can see that over in this area we got 772. Over here we got 772. And over here we got 772. These are several different ways using base 10 to be able to subtract. So practice this on the 4 problems that are to the left. There's an addition on the bottom. On the back side, there's another subtraction, another addition, and another subtraction. Don't get confused how the numbers work. Be able to solve it using place values. Look at your operations closely before you attempt to solve any of these algorithms. I hope this was explained a little bit better. And as you're solving these, that you can use the base 10 method for reasoning how you got your difference for subtraction and how you got your sum for addition.